My name is Michael and this is my presentation on electric propulsion. You may have heard of the ion drives which power spaceships in sci-fi movies and novels. But did you know that ion propulsion is actually also a type of electric propulsion? And if you didn't know what ion propulsion is, I'm about to explain. So, basically, electric propulsion describes all the means of accelerating a propellant using electrical power. But this definition is too general. There is more than one type of electric propulsion. The two most important categories are electrostatic propulsion, also called ion propulsion, which uses charged electrodes which produce electric fields to accelerate ions, and electrothermal propulsion, or plasma propulsion, which uses electromagnetic fields to heat up propellant to a plasma state and then directs it with magnetic fields. These categories have their separate variations of thruster, so for now I will describe to you exactly how a certain type of electrostatic thruster, called a gridded ion thruster, works. Step 1. The neutral atoms of the fuel are released from the propellant tank into the ionization chamber. Normally, the fuel used is xenon gas. This is because it is very unreactive. Step 2. An electron gun, also known as a hot cathode, bombards the neutral atoms with electrons. Step 3. This electron bombardment ionizes the fuel, pushing other electrons from the atoms and causing positive ions to form. These are represented by the green disks. Step 4. The ions diffuse through the chamber and are concentrated into a beam by these magnetic rings. This increases the efficiency of the thruster. Step 5. So, the positive ions diffuse through the chamber towards the positive and negative grids. These both have current running through them, which means that they produce electric fields. But surely, I hear you say, the positive ions will be repelled from the positive grid. But no, because the negative grid has a higher voltage supply to it, which means that its electric field is stronger. So overall, the ions are attracted towards the grid. Step 6. The positive fuel ions diffuse between the positive and negative grids, interacting with their electric fields, attracted by the negative and repelled by the positive grid. The particles accelerate massively and shoot out of the thruster at high speeds. The thruster moves due to Newton's third law of motion, which states that, for every action, there is an equal and opposite reaction. This means that for every particle flying out of the thruster, the spacecraft experiences the same force as the particle, but in the opposite direction to which the particle is moving. Step 8. Before I finish, however, I have to talk about this electron gun on the back of the spacecraft. It shoots electrons at the positive ions exiting the spacecraft and makes them neutral. This prevents them from being attracted back to the thruster and cancelling any thrust. So, let's talk about a recent use of electric propulsion. Deep Space One, launched on 24th October 1998, was a technology demonstrator spacecraft. It undertook flybys of asteroids and comets as part of the New Millennium program, testing the most advanced technologies of its time with huge success. It was powered by an NSTAR gridded ion thruster, similar to the diagram I just showed, and reached a top speed of 16,200 km an hour. Today, only rockets can get us into orbit. Electric propulsion, for now, can only be used effectively in space. But why is it better? Electric propulsion is much more efficient than rockets. This means that the same thrust is produced with much less fuel than a rocket. But anyway, let's look to the future. An electrothermal thruster called Vasimir is a thruster being developed in the USA whose creators claim that it will be able to get to Mars in just 39 days. Amazing, since it took Curiosity the rover 256 days to get to the same place. So, human transport to Mars or any other planet and their moons does mean bigger rockets in terms of getting people off Earth. But electric propulsion, I think, has set itself as a major cornerstone scientists and engineers need to conquer in order for us to get to these places in reasonable timeframes. It also means more energy. New energy sources such as fusion will not only revolutionize how humans on Earth sustain themselves, but could also provide the power needed to let electric propulsion reach its full potential and allow for even faster transport in space. These topics, however, are all on the extreme edge of research. The best scientists and engineers will have to work on projects like these to make them work. Thank you for listening.